Alrighty, so now we are going to start looking at analyzing graphs of functions. So the first thing we want to do is figure out where a graph is increasing, decreasing, or where it's constant. So increasing just means going up. Where is your graph going up? Decreasing, sorry about that. Where is decreasing? Where is that going down? And constant, where is it staying the same? Staying the same. And those are going to be where we look at where it's horizontal. Where it's not going up or down, it's just going straight across. All right, so you'll notice in number 2, I added arrows. To this graph to show that it goes on and on and on and on forever. All right, so where is it increasing? Well, you'll notice that it's going to be increasing. Let me see if I can get a highlighter to help us with this part. It's increasing from here to here. So that's where it's increasing. And so on what interval is it increasing? Well, we look at the x values there. So from 4 to 8. So between 4 and 8, or from 4 to 8, this graph is increasing. Okay? Where is it decreasing? So let me get a different highlighter color. Well, you'll notice it's decreasing right there. It's decreasing there. And where is that interval? Well, that interval is from 2 to 4. So from 2, not TO, from 2 to 4, this graph is decreasing. And then where is it constant? Where is it staying the same? Well, you'll notice it's happening at 2 places. That's happening here and it's happening at the beginning of my graph and at the end of my graph. So looking at the beginning of my graph, where does that start? Well, that starts all the way out at negative infinity. So this is going to be from negative infinity all the way to 2. And then, where does it become constant again? Well, at the end of my graph, where it starts at 8, so from 8 all the way to positive infinity. Okay? So that is that graph. Go ahead and try out letter B, the one right next to it. Okay, so you can check your work there. You'll notice it's increasing from 4 to infinity. And it's decreasing all the way from negative infinity to 4, and it's never staying the same. There's no horizontal lines there. Okay, so understanding where graphs are increasing, decreasing, or constant is going to help us when we're dealing with story graphs. All right, so here we want to choose the graph that best represents each situation. So we have 3 different graphs which are going to each represent a tomato plant growing. So it's very important to recognize what's going on in each one. Where are they increasing? Are they decreasing at all? Look at the different steepness. Is it growing faster? So these are all questions we should be asking ourselves. So the first story is a tomato plant grows taller at a steady pace. So that steady pace is saying that it's staying the same as it's growing. So which of these graphs is staying the same? Graph C is staying the same. So graph C is going to represent this first story because you notice as time increases, that height increases as well at a regular pace. All right, and then in B is saying a tomato plant grows quickly at first and then remains at a constant, keyword there, remains at a constant keyword height during a dry spell, and then grows at a steady pace, so at a little slower of a pace. So which one of your graphs has a constant to it? Well, that's graph B. And if you'll notice what's going on, it's growing really high, really fast, and then it has a dry spell where it doesn't grow at all, and then it just starts growing at a regular, slower pace. All right, so that's going to be graph B. And then, obviously, we could, by order of elimination and all that stuff, we know that graph A is going to be C, but let's see why. So A tomato plant grows at a slow pace, and then grows rapidly with more sun and water. So if you'll notice this line is just going up at a slow and steady pace. It then gets a lot steeper here, which means that it's getting taller over a smaller amount of time. So that's why that one, or is graph, oh, I'm sorry, not graph C. Wrong. Graph A. Okay? So those are how you analyze story graphs. You could also analyze them, or you might have a question like this. So go ahead and try this practice problem. Alrighty, so the best option for this is letter D, because your temperature is increasing and then steadies out, so then it stays constant and doesn't change at all over time, and then shoots up rapidly. It gets a lot steeper. Notice how your graph isn't decreasing at all, so that's going to eliminate options A and option C. And then notice how your graph starts by increasing, so it doesn't start constant, then increase, and then go back to constant. So that's how you eliminate A, B, and C. All right, now the last part of this is going to be story graphs. So if I look at this situation, this graph represents Tom skateboarding around town. He starts at home, and then he wants to skateboard to the park and then go back. So he's going up, and then he's going up at a fast rate, then he slows his pace down. He gets to the park, and then he heads back home. All right, so these 2 points represent his house or his home, and this point represents the park. So let's answer these questions. What is a reasonable domain and range for this situation? So remember, domain is your x values. So if I look at the x-axis, it starts from 0. So he starts at 0, and he goes all the way to about, I'll say 67. From 0 to 67 minutes. And then the range, remember the range is going to be your y values. So if I look at the y values, that's going to go from 0, also starts at 0, but goes to about, and I'm going to draw this line over here just to see where it's going to hit, goes from 0 to about 3.5. 0 to 3.5 miles. Because you'll notice the x-axis represents your domain, and that's going to be time in minutes. And then the y-axis is going to be your distance in miles. All right, so now the next question is asking us, what does this point 10 to mean in the context of the problem? Well, remember that coordinates are going to be in the form of x comma y. All right, so 10 is going to be my x-axis, and the x-axis is time. So after 10 minutes, what does that 2 represent? So 10-2 is about right here. After 10 minutes, Tom is 2 miles away from his house, going towards the park. So right there, at 10 minutes, he's 2 miles away, and then he is on his way towards the park because he hasn't quite gotten to the park yet. All right, approximately how long does it take for Tom to get back home, round trip? Well, you notice he started at home, went fast, then steadied out, then got to the park, and then went back home. Well, how long did this entire trip take? It took about 67 minutes. His whole trip took about 67 minutes. And then the last question is asking us where the park is. Well, we already labeled the park when I introduced this problem. So the park is right here. approximately how far does it take Tom to get there? So I'm going to say this, I'm going to rewrite this question. Actually, how far and how long did it take Tom to get there? Well, if I'm going to just draw this down. And draw this across just so I can see, it took Tom about, if I look at the x-axis, about 40 minutes to get to the park. Which is about 3.5 away from his house. 3.5 miles away from his house. Okay? So that's where the park is. Those are the types of questions that you'll be asked for with story graphs. It's very important that you understand that idea of increasing, decreasing, staying constant, and then how to pull information away from that graph in order to match a real life situation. Make sure you ask your questions, do your work. As always, be safe and be good.